Lesson 5, Linear Type 1. We have to find the equation of the locus of a point such that it is equidistant from these lines x plus 2y minus 1 equals 0 and x plus 2y plus 5 equals 0. You'll notice because the coefficients of the x and the y's are the same, then these lines will be parallel. You can just, if you rearrange the equation and make y the subject, you'll see that they'll have the same gradient. Now, but you don't need to do that. Now, what we'll do now is we'll just sketch these lines. Take the first one, okay, when x equals 0, and say x equals 0, x equals 0, we can see that 2y minus 1 equals 0, so y equals a half. That gives the y-intercept here. And when y equals 0, we can see that x minus 1 equals 0, so x equals 1. So we've got this one over here. So that will go that way. Now, the other one, when x equals 0, we can see that 2y plus 5 equals 0, so y equals minus 2.5. Down here, minus 2.5. Now, we can get the other intercept, but it's not necessary. We know it's parallel. So we're going to go through here. So there are the lines there. Now they're equidistant. So that means that the midpoint here has to be the same either side, right? So that distance must equal that distance. Okay. Now to do that, all we need to do is work at the midpoint. So we're going to have here, this is remember 0.5. And this one down here is 0 minus 2.5. 2.5. Okay. Now a half plus minus 2.5 is going to be minus 2. Divide that by 2, you get minus 1. There's the y-intercept there. Now to work out that equation, this one, because it's parallel to the others, will be able to form x plus 2y plus some constant k equals 0. Now at this point here we know x equals 0, and we know that y equals negative 1. So it's minus 2 plus k equals 0, so k is equal to 2. So the equation of this locus is x plus 2y plus 2 equals 0. It's the equation of this locus, and that's the one method of doing it. Alright, now the other way of doing it, we'll call this method 2. Method 2, Method 2 is using the formula perpendicular distance equals the absolute value of ax1 plus by1 plus c all over the square root of a squared plus b squared. But you've got another formula to do this one. Do it this way. Now, say we take a point here, our general point pxy, and we're saying that distance there must equal that distance there. Right, that's the perpendicular distance there. Alright, now, starting off, we can say, first of all, looking at this line, right, now remember this one was this one here, we can say the first distance, p1, is equal to, we just write x plus 2y minus 1, because it's a general point, all over the square root of these coefficient squares. That's 1 squared plus 2 squared, which gives me 5, root 5. The second one, p2, equals the absolute value of x plus 2y plus 5 all over the square root of 5. Now p1 equals p2. Therefore, the absolute value of x plus 2y minus 1 equals the absolute value of x plus 2y plus 5. And these root 5s go out. Now, there's two ways you can do this. You can have x plus 2y minus 1 equals x plus 2y plus 5, removing the absolute value signs. But as you can see from that, you get minus 1 equals 5. So that's no good. So because the reason is that there's the distance that way, and you're going in the opposite direction to get the other distance. So what you have to do is go x plus 2y minus 1 equals minus x minus 2y minus 5. Taking this across, you get 2x plus 4y, and this becomes minus 4 equals 0, and then divide through by 2, and we get, I beg your pardon, plus 4, because you're adding 5 to both sides. You get x plus 2y plus 2 equals 0, which was the same as we got before.